Today our topic is percentage composition, empirical formula and molecular formula. Percentage composition. What is percentage composition? It is the percentage of different elements present in a compound. That is percentage composition. Percentage of different elements present in a compound. How will you calculate percentage of an element? Percentage of an element is equal to mass of the element in the compound divided by molar mass of the compound into 100. So percentage of an element, that is mass percentage. Mass percentage of an element is equal to mass of the element in the compound divided by molar mass of the compound into 100. So what is percentage composition? Percentage composition of a compound is the mass percentage of different elements present in the compound. An example, calculate percentage composition of CO2. We know the molecular mass of CO2 is 44 and it contains 12 gram carbon and 16 plus 16, 32 gram oxygen. Therefore, percentage of carbon is equal to mass of carbon in the compound, that is 12, divided by molar mass of carbon dioxide, that is 44, into 100. 12 by 44 into 100, 27.27 is the percentage of carbon in CO2. Percentage of oxygen. Mass of oxygen 16 into 2, 32, divided by 44, molecular mass of CO2, into 100, 72.73. It is percentage composition. Very easy to find out percentage composition of various compounds. For example, calculate percentage composition of KClO3. Here we have to find out the percentage of potassium, percentage of chlorine, and percentage of oxygen. To calculate mass percentage of an element, mass of the element in the compound divided by molar mass of the compound into 100. Percentage of potassium, 39 by 122.5, that is the molecular mass of KClO3, into 100, 31.84. Percentage of chlorine, 35.5, atomic mass of chlorine, divided by 122.5 into 100, 28.98. Here there is only one chlorine. But oxygen, there are 3 oxygen atoms in the compound. Therefore, percentage of oxygen is equal to 3 into 16 divided by 122.5. 3 into 16, 48, 39.18. Now a homework for you. Calculate the percentage composition of various elements in magnesium sulfate. You know, atomic mass of magnesium 24, sulfur 32, oxygen 60. Then you can easily calculate it. Okay, now empirical formula and molecular formula. What is empirical formula? Empirical formula is the relative number of different atoms present in a compound. Or it is the simplest ratio of different atoms present in the compound. Simplest ratio of different atoms present in a compound. So what is empirical formula? Empirical formula represents the simplest whole number ratio of various atoms present in a compound. What is molecular formula? Molecular formula represents the exact number of different atoms present in a compound. Exact number of different atoms present in a compound or present in a molecule. That is molecular formula. Now, how this empirical formula and molecular formula are related? We can show the relationship using the equation. Molecular formula is equal to N into empirical formula. Molecular formula is equal to N into empirical formula. Then what is N? N is a whole number. We can calculate N using the equation N is equal to molecular mass divided by empirical formula mass. Molecular mass divided by empirical formula mass. What is empirical formula mass? It is calculated from empirical formula. Sum of atomic masses of different elements present in the compound. Sum of atomic masses of all the atoms present in the empirical formula. That is empirical formula mass. Sum of atomic masses of all the atoms present in the empirical formula. So it is the relationship between molecular mass and empirical formula mass. To understand it, we can solve an example. Empirical formula of benzene is CH. Empirical formula mass, then what is empirical formula mass? 12 plus 1, 30. Molecular mass of benzene, 78. Molecular mass of benzene. So N is equal to 78 by 13 equal to 6. So molecular formula N into empirical formula, that is 6 into CH equal to C6H6. That is the molecular formula of benzene. Okay, now a problem to find out the molecular formula. An inorganic salt gave the following percentage composition: sodium 29.11, sulfur 40.51, and oxygen 30.38. Calculate the empirical formula and molecular formula of the compound if its molecular mass is 158. In order to solve this problem, it is better to use such a table. If you use such a table, it will be very easy for you to solve this problem. And this table contains 6 columns. The first column, you have to write the symbols of the elements. Second column, percentage of element. That is given here. Percentage composition, 29.11, 40.51, 30.38. Third column, atomic mass of element. Oxygen 16, sulfur 32, sodium 23. Then in the next column, relative number of moles. How will you find out relative number of moles? That is given here. Percentage of element divided by atomic mass of element. That is relative number of moles. Then simplest molar ratio. How will you find out it? Relative number of moles divided by smallest relative number of moles. Then simplest whole number ratio. Okay, when we solve it, you will understand it properly. First one, sodium 29.11. Sodium 29.11. When you arrange the elements here, that should be in the increasing order of electronegativity. The most electropositive will be the first one. So sodium here, then sulfur, then oxygen. So sodium percentage is 29.11. Atomic mass 23. Relative number of moles 29.11 divided by 23 equal to 1.266. Then second, sulfur 40.51 is the percentage. Atomic mass 32. Relative number of moles 40.51 divided by 32 equal to 1.266. Next, oxygen percentage 30.38, atomic mass 16. Relative number of moles 30.38 divided by 16 is equal to 1.897. Now you check which is the smallest relative number of moles. Here 1.226, 1.226, 1.897. Which is the smallest? 1.226. So divide all relative number of moles with the 1.226. 1.226 divided by 1.226. 1.266. 1.266 divided by 1.266 equal to 1. 1.897 divided by 1.266 equal to 1.5. Here the numbers are not whole number, therefore we have to multiply these numbers with a suitable number to get whole numbers. Here 2 is selected as the suitable number. So 1 into 2, 2, 1 into 2, 2, 1.5 into 2, 3. Here it is the number of different atoms. Means 2 sodium is present, 2 sulfur is present, 3 oxygen is present. Therefore, we can write empirical formula as Na2S2O3. Then what is N? Number of molecular mass divided by empirical formula mass. Molecular mass 158, that is given here. If you calculate empirical formula mass, then again you will get 158, 158, 23 plus Na2S2, 23 plus 23 plus 32 plus 32 plus 16 plus 16 plus 63. You will get 158. The ratio is equal to 1. If the ratio is 1, what is the meaning? Empirical formula and molecular formula are the same. Molecular formula is Na2S2O3. You can see another question here. A compound contains 4.07% hydrogen, 24.27% carbon, and 71.65% chlorine. Smaller mass is 98.96 gram. What are its empirical and molecular formula? Our table, first to draw the table, write everything, and write. In the case of organic compounds, you have to write carbon first. Then in the order of increasing electronegativity. So, however, in organic chemistry, you have to write the element carbon first. Then the next one, hydrogen, chlorine. Write percentage of element. Carbon 24.27 is given here. Carbon. Hydrogen 4.07 and chlorine 71.65. Atomic mass, carbon 12, hydrogen 1 and chlorine 35.5. Now we have to calculate relative number of moles. Percentage divided by atomic mass, 24.27 divided by 12. 2.02, 4.07 divided by 1, 4.07, 71.65 divided by 35.5, 2.02 we can approximate, 2.02. Here when you compare the relative number of moles, we can see 2.02 is the smallest. Divide all relative number of moles with the 2.02. 2.02 by 2.02, 1, 4.07 divided by 2.02, 2, 2.02 divided by 2.02 equal to 1. So relative number of different atoms, 1, 2, 1. Carbon 1, hydrogen 2, chlorine 1. So the empirical formula CH2Cl. We can find out N, molar mass divided by empirical formula mass equal to 98.96 divided by 49.5 equal to 2. Molecular formula N into empirical formula, that is 2 into CH2Cl equal to C2H4Cl2. I think it is clear to you. Now 2 homeworks for you. A compound containing carbon, hydrogen, and oxygen gave the following analytical data: carbon 40.0% and hydrogen 6.67%. Here you can see the percentage of oxygen is not given, but clearly here mentioned oxygen is present. So there are 3 elements: carbon, hydrogen, and oxygen. How will you find out the percentage of oxygen? 100 minus some of the percentages of carbon and hydrogen. So total is 100. So if you know the percentage of carbon and hydrogen, then you can find out the percentage of oxygen using the equation 100 minus percentage of carbon plus percentage of hydrogen. In the third question also the same case. An organic liquid having carbon, hydrogen, nitrogen, and oxygen was found to contain 41.37% carbon, 5.75% hydrogen, 16.09% nitrogen. Okay, here also the problem is there. Carbon, hydrogen, and nitrogen are given, but oxygen is not given. Clearly, it is mentioned oxygen is there. Will you get the percentage of oxygen? 100 minus some of the percentages of other elements. And here, instead of molecular mass, vapor density is given as 43.3. Then what is molecular mass? Molecular mass 2 into vapor density. Okay, all of you have to solve the problems, write the notes and submit it in the Google.